In this lesson, we're looking at applying the exponential probability distribution function. So we can see here, just as a recap, the function is lambda e to the negative lambda x. And we can see that when we're looking at using the cumulative distribution function, we use the integral between 0 and x, which gives us f of x is 1 take e to the negative lambda x. All right, so we'll start with a nice easy example. So in this example, it says the time x minutes that a shop assistant waits before the next customer arrives is known to be exponentially distributed, and it's given by the function f of x is equal to 0.2 e to the negative 0.2 x, where x is greater than or equal to 0. And we want to find the probability that he will wait more than 8 minutes for the next customer. So we're looking at the probability that x is greater than or equal to 8. So we're looking at the probability that x is greater than 8. And so this can be approximated by the integral between 8 and infinity, so more than 8, of 0.2 e to the negative 0.2 x with respect to x. And so that is negative e to the negative 0.2 x between 8 and infinity, and the limit as k approaches infinity, negative e to the negative 0.2 x between 8 and k. So when we look at the first part, so the limit as k approaches infinity of negative e to the negative 0.2 k, and then subtract negative e to negative 0.2 times 8. Now, as k approaches infinity, e to the negative 0.2 k approaches 0. So we've got 0 subtract a negative, which is plus, e to the negative 1.6. And so that means our probability that x is greater than 8 is 0.2019 approximately. And so that probability that he waits more than 8 minutes for the next customer to arrive is about 20.2%. So if we look at that same example and we want to find the mean and standard deviation, we know that the mean is equal to 1 on lambda, and we know that the standard deviation is equal to 1 on lambda. Now lambda is simply, in this case, 0.2. So we're looking at 1 on 1/5, which means our mean is 5 minutes. And standard deviation will be the same. It will be 1 on 1/5, which will be 5 minutes. So the mean and the standard deviation will be 5 minutes. So as we keep on moving forward, we're looking at another example. In this case, the time, t minutes, that it takes a librarian to locate a book is exponentially distributed with a mean of 3 minutes. So we know the function will be lambda e to the negative lambda t, lambda x, where our mean, e of x, is equal to 3. And so that means e of x is also equal to 1 on lambda, 3 is equal to 1 on lambda, and therefore lambda is equal to 1 on 3. Now that we know lambda, we can say, so using the time t minutes, we've got f of t is equal to 1/3 e to the negative 1/3 t. And that's part A done. So when we look at part B and we're looking at the probability that it takes less than 2 minutes to find a book, then what we're looking at is the probability that t is less than 2, which is the integral between 0 and 2 of 1/3 e to the negative 1/3 t with respect to t. And so that means we're looking at negative e to the negative 1/3 t between 2 and 0, and that is negative e to the negative 2/3, subtract negative e to the power of 0, and so that means we have 1 subtract e to the negative 2/3, which gives us a probability which is approximately 0.4866, or approximately 48.66% chance. Okay, so another nice easy example. You can see how easy it is to find lambda now that we understand its relationship with the mean and the standard deviation, and how easy it is to find that probability of it being less than 2. We could have also used the cumulative distribution function up here, this 1 subtract e to the negative lambda x. You can see how that correlates. Alright, so last example. Now we have we've got the same situation from example 20, so that means that we've got our function f of x is equal to 0.2 e to the negative 0.2 x, and now we're looking at the probability that it's between 5 and 10. So that means we're looking at an integral between 10 and 5 of 0.2 e to the negative 0.2 x with respect to x. And so that means that we're looking at f of 10 subtract f of 5. So if I use the cumulative distribution function, that will be 1 take e to the negative 0.2 times 10 subtract 1 take e to the negative 0.2 times 5. And so that is 1 subtract e to the negative 2 subtract 1 take e to the negative 1. And so 1 subtract 1, we have e to the negative 1 subtract e to the negative 2, and that will approximately be equal to 0.2325, or 23.25% chance. Alright, so the probability that the shop assistant waits between 5 and 10 minutes is 23.25%. Alright, so that concludes the lesson. You can see these are pretty easy to apply, particularly if you're confident with your integrals involving exponentials, and you probably can also see that it always comes out as that same thing. So remembering that cumulative distribution function does make life a lot easier. Alright, so thank you for listening.